Calculate the degree of dissociation of alpha for acetic acids. If its molar conductivity lambda m is, they are given 39.05 Simon centimeter square per mole. They are given the lambda naught value for H plus ion and CH3CO minus ion. So what we have to calculate here, we have to calculate the degree of dissociation. So degree of dissociation alpha, the formula for alpha is lambda m by lambda naught, right? So lambda m of acetic acid has been given here. So we have to find out the lambda naught m by using these two values. So the lambda naught m of CH3COOH, that is equal to nothing but the plus of these two things, that is the lambda naught of acetate ion, that is CH3COO minus plus lambda naught of H plus ion. So simply we can add this one, that is 3 no 40.9 plus 349.68, right? So if we add this one, we can get the value 390.5, right? 390.5. Substitute this in this value, that is, it is already given here 39.05. 39.05 by the value what we got, 390.5, right? So the value will be, here we can cancel 1 upon 10, that is equal to 0.1, right? 0.1. So this is the degree of dissociation of this particular acetic acid. Got it? The conductivity of 0.2 m solution of KCl at 298 Kelvin is 0.025 Simon per centimeter. Calculate its molar conductivity. We have to calculate the molar conductivity. So let us write the formula for molar conductivity, that is equal to kappa into 1000 by m or c. Okay, concentration. So we can substitute here kappa, the value of kappa conductivity. It has been given us 0.025. 0.025 Simon per centimeter into 1000 by concentration of the solution, that is nothing but 0.20. So this will be equal to, let's cancel here, this can be written as 0.02. The conductivity of 0.2 m solution of KCl at 298 Kelvin, that is equal to 0.025 Simon per centimeter. So this is the conductivity, that is the kappa value. Calculate its molar conductivity. They are asking for the molar conductivity. So let us write the formula here. So molar conductivity, that is equal to kappa into 1000 by m. Concentration, that is equal to kappa, the value of kappa is 0.025 into 1000 by concentration, that is equal to 0.20, right? So to make the simplification, to cut down the zeros, we can write as this term as this is 25 by 1000 into 1000. So to make this one, we can write it as by 20 into 100, right? So these two decimals to cut off, right? So we can cancel 1000 here. So we can have 0 get cancelled here. So 2 into 5, right? So finally 25 into 5, that is equal to 125. So 125, write the unit as it is. So Simon centimeter square per mole, right? So this is the answer. The conductivity of 0.2 mole per liter solution, the concentration of KCl is 2.48 into the power of -2 Simons per centimeter. So the value of kappa, right? Calculate its molar conductivity and degree of dissociation. So we have to calculate its molar conductivity and degree of dissociation. So what they had given the value of lambda of K plus, lambda naught of K plus, and lambda naught of Cl minus. So we can work it out. So what they had given, concentration, molarity they had given. So by using, we can use a formula to conduct the molar conductivity, that is molar conductivity that is equal to kappa into 1000. Kappa into 1000 by concentration C or M, it will be here. So what is the value of kappa here? 2.48 into 10 to the power of minus 2 into 1000 into 1000 divided by, what is that, concentration that given us 0.20 mole per liter, right? So this can be written as, point naught 248 into 1000 by 0.20. Am I right? 0.20. So this is equal to 124, right? 124, 124 Simon centimeter square per mole, right? Simon centimeter square per mole. So we had calculated the molar conductivity, right? Molar conductivity of the solution. So we have to go for alpha now, right? We have to go for alpha now. So what is alpha? Alpha is equal to conductivity by limiting molar conductivity. Molar conductivity by limiting molar conductivity. So that is equal to lambda naught m. We can calculate by using this formula. That is K plus and Cl minus. If we simply add this one, we can get the formula. That is the lambda naught value of KCl. That is equal to, simply add these two things. That is 73.5 plus 76.5. So if we add both the things, we can get the value, or we can simply add here. What the value we found out? 124. So 124 divided by 73.5 plus 76.5. So that is equal to 0.82. That is equal to 0.82. So this is the value we have to obtain, right? This is the degree of dissociation. This is a molar conductivity. Got it? How much charge? How much charge in terms of Faraday is required to reduce 1 mole of M1O4 minus to M12 plus. So we know that the charge required formula is charge required. So that is equal to NF. N means, the number of electrons, F is Faraday. So M1O4 minus, MnO4 minus has been gone to M12 plus. M12 plus. Here the oxidation state is +7. Here the oxidation state is 2 plus. Right? What is the difference in electrons then? 5 electrons. So N is equal to 5 here. So Faraday we know the value. So that is equal to 5 into 965,002. So that is the answer here. Check out the answer. And next question. Calculate the mass of silver deposited at cathode when a current of 2 ampere was passed through a solution of AgNO3 for 15 minutes. So they are asking for mass of AgNO3. Remember the formula. Mass is equal to Z. Remember this formula. W is equal to ZIT. Right? And Z is equal to molar mass by NF. Molar mass by NF. Okay. Now, so what is this AgNO3 here? How AgNO3 dissociates? AgNO3 dissociates into Ag plus NO3 minus. Right? So it means that Ag plus accepts one electron to become Ag. Right? So here, what is this? The N is one electron. So if we substitute this formula, so W is equal to, what is that? Molar mass. What is the molar mass of Ag here? 108. Right? So 108 by 1 into 96500. That is NF. 1 into 965. This is the thing. Z value. Right? Into, what is I here? Current. 2 ampere. What is the time here? They had given us 15 minutes. So we have to always use the minutes in seconds. So 15 into 60. So 15 into 60. Got it? So find out the value. That is the answer. Here. A solution of NaNO3 twice is electrolyzed between platinum electrodes using a current of 5 ampere in 20 minutes. What is the mass of nickel deposited at the cathode? Right? Mass of the nickel. So mass of the nickel, what is the formula? W is equal to Z. ZIT. What is Z here? Z is equal to molar mass by NF. Right? So what happened here? Nickel nitrate is electrolyzed here. So here let us write the equation NiNO3 twice. So it electrolyzed. It gives Ni2 plus NO3 minus. So what happens here? This Ni2 plus should get 2 electrons to become as Na, right? So the number of electrons involved here is 2. So let us substitute in this formula, that is mass is equal to molar mass. What is the molar mass? Molar mass of NaNO3 twice. So it is average 59 by what is the number of electrons involved? 2 into Faraday 96500 into current. What is the current used here? 5 ampere into time into what's the time? 20 minutes. It should be taken in seconds. So 20 into 60, right? So this is it, 20 into 60. So the answer will be 1.825. Whatever the answer obtained, that is in grams, right? That is in grams. Got it? Simple. If mass is asked, we can use this formula. Right. So how much electricity in terms of Faradays is required to produce 20 gram of calcium from molten CaCl2, right? So let us write the equation for CaCl2 here. The CaCl2 dissociates as Ca2 plus 2Cl minus, right? So the Ca2 plus, it requires 2 electrons to get converted into Ca. So how many electrons required? 2 electrons. So the amount of electricity required, 2 Faradays. So the mass of calcium is 40 grams here, right? So now we have to understand here, for producing 40 grams of calcium, 40 grams, 40 grams of calcium, how much electricity is required? 2 Faradays required, or 2 Faradays required. So here we have to get 20 gram of calcium. So 20 gram of calcium, for 20 gram of calcium, so we can use the unitary method here, that is 2 by 40 into 20. So if we cancel it, 2. So 2 by 2, that is equal to 1. So the answer is 1 Faraday. Got it? The answer is 1 Faraday here.